Good morning. Today we are graphing quadratic equations, and this process is going to be very similar as the ones that we cover on absolute value functions, but we are going to be having two forms. We're going to have the vertex form and standard form. We know that a quadratic equation has a form of ax squared plus bx plus c, where the largest exponent is x squared, since a cannot be equal to 0. Its graph is a U-shape and it's called a parabola. Now if you notice, this ax squared plus bx plus c, it's the standard form. We're first going to be looking at the vertex form on the first two examples, and on the back side we'll be looking at the standard form. We have a parabola. If the value of a on either one of those two forms is positive, we know the parabola will be facing up. If the value of a is negative, we know that our parabola will be flipped and will be facing down. We are going to have the same components as the absolute value. We're going to have a vertex, and we're also going to be having our line of symmetry. And as you guys can tell, if it's on vertex form, our vertex will be h and k. The axis of symmetry will be x is equal to h. On the standard form, we're going to have to find the vertex, and they're giving us a formula for the vertex, and the axis of symmetry will be the x value of the vertex. Same thing as the vertex form. But let's go and start on example number 1. On example number 1, we have a quadratic equation because we have an x squared, and it's on vertex form. And I'll write down the equation right above it so we can find the h and the k. So remember, the vertex form is y is equal to a x minus h squared plus k. Very similar to the absolute value functions. So the first thing that we need to do, we need to be able to find our vertex. So our vertex is going to be h and k, so this will be positive 1. Remember, because our formula says negative h, so that'll be positive 1, comma, negative 4. So positive 1 and down 4. That'll be our vertex. Now, our line of symmetry will go through the vertex, and the equation, where does it cross the x-axis? At 1. X is equal to 1. Be sure to write down the equation of the axis of symmetry. By the definition above, you can also note that that will be, this is your x value, so x is equal to 1. The equation for the line of symmetry will always be your h value, or the x value of the vertex. Now, many of you guys are going to be tempted to just go use this as the slope, because this is a quadratic equation. This is no longer the slope, so we need to be able to make a table of values. I'm going to make my table of values on the left hand side. I'm going to write in the equation y is equal to 2 x minus 1 squared minus 4. Now, I need to be able to plug in different values for x. This is your x, and we'll get the value of y. Now, you guys can plug in any values that you guys want. So if you want to plug in a 5 for x is fine. If you want to plug in a 10 is fine. If you want to plug in a negative 4, it's up to you. I like to make my life easy. So I'm always going to choose points to the right. This is a 1, so I'm going to go up 2. So I'm going to plug in a 2. If you think about it, if you want to think of a different way, this is your 1, so add 1 to the h, or to the x value, and that gives you a 2. I'm going to plug into the equation. So 2, instead of x will be a 2 minus 1 squared minus 4. I'm going to simplify what's inside, so it gives me 2. 2 minus 1 is 1 squared minus 4. I'm going to square first, so it gives me 2. 1 squared is 1 minus 4, so 2 minus 4 is negative 2. That'll be my y value. So my first point is 2 comma negative 2. So my first point is from the origin to the right 2 and down 2. And because this is symmetrical, what I do on one side, I need to do to the other side. The next one will be a 3. I'm going to continue going to the right, so I select this was 1, then 2, now we go 3, so I can get the next point here. So it'll be 2. Instead of the x will be a 3, that's what I'm substituting, minus 1 squared minus 4. I must simplify what's inside, so 2, 3 minus 1 is 2 squared minus 4. Remember, I'm going to use my exponents first, so 2 squared is 4 times 2, it's 8, minus 4 is 4. So 3 comma 4 is my next point. 1 from the origin, 1, 2, 3, and up 4. 1, 2, 3, 4. And my other point will be exactly on the same line because of the line of symmetry. From here, I'm going to go and sketch my line, my graph. Remember, this is not a absolute value, so it has to be rounded on the bottom. It's not a V, it's a U. If you notice, this is not the slope, because if this was the slope, then we'll be going up to the right one, up to the right one, up to the right one, up to the right one. And that will be a V. This is no longer an absolute value equation. This is a quadratic equation. So do not think of this as your slope any longer. But we can use it to be able to compare the transformation. We can do that. First, the transformation. We need to be able to decide if the original is wider or narrower. And we can use the A value to be able to compare it. So think of this as the first one. Is 3 bigger than 2 or 3 smaller than 2? It's bigger, so that means that this is going to be narrow. Or we can think of this one is smaller, so it's going to be wider. So let's call this f of x. So f of x, the first graph will be wider than g of x. We're going to make this a g of x. So this first graph will be wider than the second graph. Now we need to be able to compare the translation, so let's go and just find the vertex for this, which is negative 1 comma 0, negative 1 comma 0, so it'll be right here. So we got to shift from here to here, so we're going to go up 1, 2, 3, 4, and to the left 2. So up 4 and to the left 2. And we're going to call this g of x. Let's continue with the next problem. Example number 2. We need to be able to graph the following equation. First, I'm going to find the vertex. The vertex is h and k, so that'll be negative 1 comma 0, because there's no k. Negative 1 comma 0 is located here. Automatically, I'm going to draw the line of symmetry, the very next step. I know it's crossing the x-axis at negative 1, so this will be x is equal to negative 1. And if you notice, the value of a is negative, so this will be facing down. But let's go and make our table values on the left-hand side, just so we have a little bit more space. Then write down the equation, negative 1 over 3 x plus 1 squared. I'm going to plug in different values for x. Now the values of x that I select, you can select any values that you want, but I'm going to go to the right. So this is negative 1, I'm going to go to 0. You can think of this negative 1, add 1, negative 1 plus 1 is 0. So let me plug in a negative 0 for the x. Instead of the x will be a 0. I'm going to simplify. That gives me 1, so negative 1/3. 1 square. 1 square is 1 times negative 1/3 gives me negative 1/3. So my next point, the y value is negative 1/3. My next point is 0, comma, negative 1/3. So 0, I stay there, and then I'm going to go down 1/3, which is here, negative. And what's on one side, it's on the other side. It should be a bit higher, but that should be fine. I'm going to go and plug in the next value. I'm going to plug in 1, so 0 plus 1 is 1. It'll be negative 1/3. That'll be 1 for the x value, plus 1 square. 1 plus 1 is 2, so negative 1/3, 2 square. I'm going to square first. Gives me negative 1/3 times 4. When I multiply a fraction by a whole number, I'm going to place over 1. I'm going to multiply across, so positive times negative is negative 4 over 3. So negative 4 over 3. So my next point will be 1 positive and down negative 4/3. Now negative 4/3, for those of you guys that are having difficulty, so first is 1, and then I'm going to go down 4/3. That means that I'm going to have to divide each section in 3. So I'm going to divide in 3. And I need to take 4. So I'm going 1, 2, 3, and I need one more third, which is right here. Right, so I'm going to divide the next one. So I'm going to divide each whole number by 3. 1, 2, 3. But I need to take 4. So I'm on 1, 2, 3, 4. So 3/4 is here. And what I do on one side, I need to do to the other side. So it's right there. And from there, I can go and shape my parabola. Now, if you want more of an exact graph, you can go ahead and plug in a 2 and a 3. But for us, that'll be sufficient. I need to be able to get 4 points. The vertex plus 4 additional points. 2 on each side. Now, we need to be able to compare the transformation. If you notice, I changed this to g of x, so that'll be much easier to be able to compare it. The transformation, I need to be able to think, is 1/3 bigger than 2/3, or it's 1/3 smaller than 2/3. Remember, it doesn't matter if it's negative or positive. We only compare the absolute value of a. So 1/3 is smaller. That means that f of x is wider than g of x. We also need to be able to compare the translation. So let me find the vertex. The vertex for this is, there's no h, so there'll be 0, 1. 0, 1 is here. So I'm going to go from f of x to g of x, so I'm going to go up 1 and to the right 1. So from f of x to g of x will be up 1 and right 1. And that'll be our translation.